Welcome student to the lecture number 2 of the chapter sound. In the first lecture, we have studied about this introduction of sound. In that, we have seen the various types of waves. The and we saw that the sound is travel in the form of wave, and the type of wave of the sound is the longitudinal wave. And we have studied all about the introduction part of the sound. Today we will see in this lecture the what is the speed of the sound, the speed of the traveling waves. As we know, the sound is nothing but it is a progressive wave. Or in the last lecture we have seen that when the wave is created, the wave is created whenever there is the we create a disturbance in the medium, and when this disturbance travels, and that means the wave is also travels, and that type of wave is nothing but the traveling wave. And in this lecture we will discuss about the speed of these traveling waves. Either it may be a transverse wave or a longitudinal wave. Let us it is we are going to discuss the speed of transverse wave as well as the speed of longitudinal waves. And also we will see in this lecture the Newton's formula for the velocity of sound in air. And also we are going to see the Laplace correction to the Newton's formula. All these points we will discuss in detail. So let us first see the speed of traveling waves. Actually, this speed of mechanical wave depends upon the elastic property and density of the medium. The same medium can support both transverse and longitudinal waves which have different speeds. As we know, the speed of mechanical wave depends upon the elastic property. What is mean by the elastic property? Elastic property is nothing but it is a property by which the material possesses its own size and shape, or it possesses its original position. Whenever we disturb the medium uh, the it starts the wave is created, and when the wave is traveling, and then as the position of the particles regain its original position, they again come back to their original position, and that is nothing but the elastic property. And as much as the elastic property of the medium, the wave travels faster in that medium. And these are the example. This one is the transverse wave, and this is the longitudinal wave. According to the velocity of particle in which the direction of velocity of particle in this transverse wave, the particle moves perpendicular to the motion of the wave, ज्या डायरेक्शन टू द डायरेक्शन ऑफ मोशन डायरेक्शन ऑफ द वेव्ह डायरेक्शन वेव्हची जी डायरेक्शन आहे त्याला परपेंडिक्युलर अशी अशी जी मोशन होते पार्टिकल्सची ज्या वेळेला होते त्यावेळेला आपण काय म्हणतो, दॅट इज द ट्रान्सवर्स वेव्ह. अँड इन द केस ऑफ लॉन्जिट्युडनल वेव्ह द direction of motion of particles of medium is in the same direction of the wave. That means the direction of particles is the direction of particles are parallel to the direction of wave. So, and we know the examples of transverse wave and longitudinal wave. The transverse wave, the best example is the light wave, and the longitudinal wave, that is sound wave. And the meaning of the second sentence, that the same medium can support both transverse and longitudinal wave, means आपल्याला माहिती आहे की एअर मधून लाईट सुद्धा पास होते आणि साऊंड सुद्धा येतो. दॅट मीन्स द एअर मीडियम allows both these waves, means transverse waves as well as the longitudinal waves. And as we know, the light has different speed and sound has different speed. Though these two waves have the different speeds, then uh, then also the medium support them. That means the medium allow them to travel through it. Okay, now the uh, that means the both transverse and longitudinal waves can travel in the same medium, though they are having the different speeds. Now let us see one by one what is the speed of this transverse wave and what is the speed, how can we derive the speed of longitudinal wave and the transverse wave. Let us see first the speed of transverse waves. Now the speed of transverse wave depends on two things. One is the restoring force produced in the medium. Now what is mean by this restoring force? This restoring force means the force by which the body possesses its own position or its equilibrium position. That is the restoring force. And this transverse speed, the speed of the transverse wave depends upon the restoring force. किती लवकरात लवकर मीडियमचे जे पार्टिकल्स आहेत ते लवकरात लवकर ओरिजिनल किंवा इक्विलिब्रियम पोझिशनला येतील, त्यावरती हा स्पीड डिपेंडेंट असतो. त्याचबरोबर दी the speed of transverse wave depends upon the inertial properties of medium. What are the inertial properties? That may be the mass, that are the mass and density. Okay, now the example of transverse wave, as we have seen, that is the light wave also, and we can now consider the string, the wave produced on the string. And in this case the restoring force is provided by the tension in the string. एखादी गिटारची तार असेल किंवा तर ती जी तेव्हा ताणलेली असते आणि त्यावेळेला जे काही त्याच्यावरती वेव्स फॉर्म होतात, दॅट आर द ट्रान्सवर्स टाईप ऑफ वेव्ह. अँड दॅट ड्यू टू द due to the tension in the string, the required restoring force will be provided to the string. The inertial property is in this case is the linear mass density. The on the string, the in this case the restoring force is provided by the tension in the string. तर जो काही ताण निर्माण झालेला आहे त्या स्ट्रिंग मध्ये, and that will provide itself the restoring force. As we know, the speed of transverse wave depends upon the restoring force and the inertial properties like the linear mass density in this case. So the linear mass density small m can be given as m upon L, where L is the length of the string, and hence we can give V is equal to root T upon M. This is the speed of transverse wave, and we need not to derive this equation because this is out of your syllabus. याचं डेरिवेशन तुम्हाला एक्झाममध्ये काही विचारलं जाणार नाही, कारण की तुमच्या सिलेबसच्या बाहेरचं आहे. सो व्ही इज इक्वल टू रूट टी बाय एम इज द फायनल डेरिवेशन फॉर द स्पीड ऑफ ट्रान्सवर्स वेव्ह. Now see this, from this equation or from this derivation we can conclude that the speed of transverse wave depends only on the properties of string, that is T and M, and not depend upon the or wavelength and frequency of the wave. या इक्वेशन वरून आपल्याला असं दिसून येतं की the speed of transverse wave कशावरती डिपेंड आहे? इट इज टोटली डिपेंड अपॉन द स्ट्रिंग प्रॉपर्टीज. आयदर it may be T, tension, restoring force, or the M, that is mass per unit length. And it does not depend upon the wavelength and frequency, कारण यामध्ये आपल्याला कुठलाही wavelength किंवा frequencyचा टर्म दिसत नाहीये. So from that we can conclude it. Okay, now let us see what is the speed of the longitudinal wave. Okay, now as we know, this is the longitudinal wave. In this आपल्याला माहिती की यामध्ये पार्टिकलची जी मोशन आहे ती कशी होते. इट इज in the direction of wave. म्हणजे direction of wave, this in this case the direction of wave is in positive x direction, and also these particles are moving in x direction to and fro. Means these particles are getting compressed and getting rarefied. That means in these longitudinal waves, there is the formation of compression and rarefaction, and this the compression and rarefaction are formed during the propagation of longitudinal wave. This is due to the elastic property of the medium. As we know, the every medium possesses the elastic property. म्हणजे कमी किंवा जास्त प्रमाणात असेल, but every medium possesses, either it may be solid, liquid or gases, they possesses somewhat the elastic property. According to the elastic property, आता इलॅस्टिक प्रॉपर्टी म्हणजे काय? जेव्हा आपण एखाद्या मीडियमला डिफॉर्म करण्याचा प्रयत्न करतो, ती पुन्हा तिच्या ओरिजिनल पोझिशन मध्ये येते. दॅट इज नथिंग बट दी इलॅस्टिक property, by the virtue of which the body regains its original size and shape. That is nothing but the elastic property of that body or of that medium. Now the this compression and rarefaction is due to the elastic प्रॉपर्टी ऑफ द मीडियम. मग त्याच्यावरून आपल्याला लक्षात येईल की जितकी जास्त इलॅस्टिसिटी असेल किंवा जितकी जास्त इलॅस्टिक प्रॉपर्टी शोन बाय दॅट मीडियम, तितक्या लवकर काय होईल, तितक्या लवकर कॉम्प्रेशन अँड रेअरफॅक्शन जास्त होईल. म्हणजेच काय, द स्पीड ऑफ द वेव्ह इज फास्टर. मग ॲज वी नो, द स्पीड of sound in solid and liquid is greater than the gases due to this property, which this is the elastic property of, due to the elastic property of medium. Because we know the elastic property of solids and liquids is greater than the gases. कारण एखाद्या आपण जर गॅसेसला डिफॉर्म केलं तर लवकर ते पुन्हा ओरिजिनल पोझिशनला येत नाहीत. अनलाइक दी in case of solids, if we deform, or in case of liquid, they try to regain their size and shape, but in case of gases it does not happen. So the speed of sound, we can see the speed of sound is greater in the solids and liquid than the gases. Okay, the speed of sound is a longitudinal wave in an ideal gas is given by the in in an ideal gas is given by the Newton's formula. The speed of sound as a longitudinal wave in an ideal gas is given by the Newton's formula. Before going to see the Newton's formula, here is one chart that is given in your textbook. The speed of sound in different gases and liquids and solids is given here. You can see in the gases at these temperatures, the speed of sound is like in the hundreds, like 259, 316, etc. And in the liquids, you can see here the speed of sound is greater than the speed of sound in gases. And among these three, in the solids, the speed is highest. See here, in the steel, the speed of sound is greatest, because we know the elastic property shown by steel is much more than these other solids, as mentioned in this table. Okay, कारण आपल्याला माहिती आहे की स्टीलची इलॅस्टिक प्रॉपर्टी ही जास्त आहे. आपण नेहमी इलॅस्टिक प्रॉपर्टी ऑफ मटेरियल गिवन बाय दी यंग्स मॉड्युलस वाय इज इक्वल टू, आपण इंटू 10⁻11 च्या फॉर्म मध्ये येतं. सो it is a very big quantity, so it shows the more elastic property, and hence it possesses the high speed of sound in the medium. Okay, Now let us see the Newton's formula for the velocity of sound. According to Newton, the velocity of sound in gas is given by V is equal to square root of E upon rho, where E is the proper modulus of elasticity of medium and rho is the density of medium. आता इथे प्रॉपर मॉड्युलस ऑफ इलास्टिसिटी असं का म्हणलंय की जो काही आपण मीडियम कन्सिडर करणार आहोत त्याची इलॅस्टिक प्रॉपर्टी किंवा त्याचा जो मॉड्युलस ऑफ इलॅस्टिसिटी आहे तो आपल्याला या ठिकाणी यूज करायचा आहे. सो दिस इज द इन जनरल फॉर्म ऑफ द न्यूटन्स formula, that is V is equal to under root E upon rho. As the sound travels through a medium in the form of compressions and rarefactions, the density of medium is greater at compression while it is smaller in rarefaction. Uh, since this, as we have seen earlier, when compression is taking place, all the particles gathered together, and at that time the wave there where is the compression is takes place, there the density increases obviously, and as there all the particles gathered, the immediate there is the formation of rarefaction, and at that place the density is smaller. So Newton assumed that the changes in volume and pressure of the gas during the propagation of sound are isothermal. Means according to Newton, आता न्यूटनचं असं म्हणणं होतं की while these things happen, while there is a compression, there is the wave releases or the particles release the means the temperature increases due to the increase in the density. त्या ठिकाणी बरेचसे पार्टिकल एकत्र आल्यामुळे there is the increase in temperature, and while rarefaction there is the particles गिव म्हणजे ज्या वेळेला ते एकत्र येतात त्यावेळेला काय होतं की टेम्परेचर इज रिलीज्ड बाय द वेव्ह, अँड व्हाईल द रेअरफॅक्शन द टेम्परेचर इज गेन्ड बाय दॅट particles. Means there is no change in the temperature, there is no change, the average temperature of the wave or the medium remains constant, while compression and rarefaction both these give and the transfer of temperature due to this gaining and gaining the temperature from the surrounding and giving the temperature or heat to the surrounding, then due to this the average temperature of the medium is remains same. So he assumed that the medium at the condition is the isothermal. आपल्याला माहिती आहे की thermodynamics मध्ये whenever there is the condition of constant temperature, then we call it as a isothermal condition or isothermal temperature, isothermal condition. So the propagation of sound are isothermal. Hence the here instead of using this E, we have to use the isothermal elasticity here. So we have to consider the isothermal elasticity instead of E, and the volume elasticity of air under isothermal change is called the isothermal bulk modulus and is equal to the atmospheric pressure P. So here the volume elasticity under the isothermal condition is nothing but it is called as the isothermal bulk modulus, and it is equal to the pressure. So we can use here instead of B, we can write V is equal to under root of P upon rho, and this is the Newton's formula for the velocity of sound. If we put the values of P and rho, then we get some value of the sound, as P is the atmospheric pressure and is given by P is equal to HdG. Then at the NTP condition, normal temperature pressure condition, the atmospheric pressure is given by P is equal to HdG, and here are the values of H, that is 0.76 m of Hg mercury column, and D is equal to 13 density, density of medium, that is air medium, D is equal to 13.6 into 10 to the power 3 kg per meter cube. Then P is here, then the density of air is here 1.29 into 1.293 kg per meter cube. And if we put all these values in this formula, that is V is equal to under root P upon rho, which is the Newton's formula for sound in air at ideal condition, then we get the value of V is approximately or is equal to 280 meter per second. But this value does not matches the value that derived earlier by the many scientists. आधीच बऱ्याच लोकांनी एक्सपेरिमेंट करून जी काही व्हॅल्यू मिळवली होती ती किती होती, दॅट इज दी 332 meter per second. And we can see here the difference between the determined value and already existing value, that is 332. मग जी काही व्हॅल्यू आधी याच्यामध्ये आपल्याला खूपच तफावत दिसते, दॅट इज अप्रॉक्सिमेटली 52 मीटर पर सेकंड. आणि आपण जर पर्सेंटेजच्या फॉर्ममध्ये जर काढलं तर दॅट इज अप टू दी 16%. दिस इज द व्हेरी बिग एरर. म्हणजे याचं एक्सप्लेनेशन द न्यूटन कुड नॉट गिव्ह द एक्सप्लेनेशन फॉर दिस. देर इज अ व्हेरी लार्ज डिफरन्स between these two values, that is the value derived by the Newton's formula and the experimental value derived by the other so many people. There is much difference, that is of 16%, and Newton could not give the satisfactory explanation for this. And to minimize or to correct this formula, the Laplace give some one another formula. We cannot say the another formula, पण वेगळा काही फॉर्म्युला असा दिलाय असं नाही. त्यांनी न्यूटन्सचाच जो फॉर्म्युला होता त्यामध्ये थोडंफार करेक्शन केले, आणि दॅट इज नोन ॲज दी Laplace correction. The Perry Simon Laplace is the French physicist who gave this correction. It is said as a correction because त्यांनी न्यूटनच्याच फॉर्म्युलामध्ये थोडंसं करेक्शन केलेलं आहे, अँड ही अज्युम्ड सम डिफरंट थिंग्स. जसं न्यूटननी काय कन्सिडर केलं होतं की द प्रोसेस, द प्रोपगेशन ऑफ वेव्ह इज इन द एअर, इन द medium, is the isothermal process. But according to the Laplace, the generation of compression and rarefaction is not a slow process. एका सेकंदामध्ये, सपोज वी टेक 250 hertz frequency tuning fork and we hit it, that means it has a 256 hertz frequency, means in one unit of time it performs 256 oscillations. Then it has that much number of compressions and rarefactions. एखादा 256 हर्ट्स असलेल्या जर आपण फ्रिक्वेन्सी जर आपण घेतली तर त्याच्यामध्ये काय होईल की देअर आर 256 टाइम्स द कॉम्प्रेशन्स अँड रेअरफॅक्शन्स टुक्स प्लेस, अँड दिस इज इन 1 second, and this is so much fast process, and there is no time for this is so rapid process. So during the compression and rarefaction there is no time to give and take such टेम्परेचर और हीट एक्सचेंज करण्यासाठी त्या ठिकाणी नॉट इनफ टाइम टू टेक अँड रिलीज और टेक दी heat from the surrounding according to the Laplace. No, now see, the heat does not get sufficient time for dissipation or to accept from the surrounding. Due to this, the total heat content remains the same, and such process in the thermodynamics we have studied that in such process in which no gain or lose of the heat, then that type of process is nothing but the adiabatic process. That means according to the Laplace, it is not an isothermal process but it is an adiabatic process. So we must uh, use, instead of the isothermal elasticity, you should here use the adiabatic elasticity in the formula. And uh, as Newton considered the isothermal elasticity, we should consider the adiabatic elasticity. And here he showed the some correction in the Newton's formula, that instead of E, just we here he used the gamma P. This is the gamma P, where gamma is the specific heat constant. That is the, it is the ratio of Cp upon Cv. What is Cp is the specific heat at constant pressure, and Cv is the specific heat at constant volume, and its value comes to be 1.41. Now if we put all these values in this formula just by doing some mathematical substitutions here, we get here the value of V 332.3 meter per second, and this value is very close to the derived derived velocity of the sound, which is derived by the many people. So by the एक्सपेरिमेंट, बऱ्याच लोकांनी एक्सपेरिमेंट करून जी व्हॅल्यू काढली होती त्याच्याशी ही व्हॅल्यू मॅच होते. सो द लॅपलॉस करेक्शन is very close to the agreement. So this is the Laplace correction to the Newton's formula. Okay, in the here the second lecture will I will end this second lecture, and in this next lecture we will see what factors does affect this sound. Sound वरती कुठल्या कुठल्या गोष्टींचा परिणाम होतो, that we will discuss in the next lecture. Okay, thank you.